Good morning, grade 5. Welcome back to grade 5 mathematics class. How are you all doing today? In this class, we're going to learn about a problem solving strategy called look for a pattern. So you have learned about patterns in a previous chapter. What do you mean by a pattern? When we have a repetition of numbers, items or objects, or groups of items or objects, series of events, and even designs, we call that as a pattern. And we can see patterns all around us. We can see a lot of patterns in nature as well as human-made things. So a pattern can be a repetition of objects, repetition of shapes, colors, designs, numbers, and even series of events. Some problems in math can be solved by identifying a pattern in the given question and then working towards the solution. For example, here you can see a pattern. We had some visual input, which are these pictures given here, and we used that input to identify the pattern and then find the solution. What if we don't have such inputs? Look at this word problem given here. A florist puts 2 flowers in a vase on Monday, 4 flowers on Tuesday, 6 flowers on Wednesday, and 8 flowers on Thursday. If this pattern continues, how many flowers will he put into a vase on Friday? So how do we find the solution? So let's write down what is given in the question. So on Monday, he'll put how many flowers? 2 flowers. On Tuesday, he'll put 4 flowers. On Wednesday, he'll put 6 flowers. On Thursday, he will put 8 flowers in the vase. And we are asked to find out how many flowers he'll put in the vase if this pattern continues. Now look at these numbers here. And these numbers seem to be in a pattern. This is counting by 2, or these numbers are even numbers. So we can easily find out what will come next. 2, 4, 6, 8. What will come next? 10. So on Friday, he'll put 10 flowers in the vase. See, we read the question carefully. We identified what all is given in the question, and we found out a pattern or a pattern rule, and then we found out the solution. So this is an example of how we can look for a pattern in a problem to find a solution. So when you try to find out the solution to a problem by applying this strategy of looking for a pattern, the goal is to look for items or numbers or series of events that are repeated. So the key to this strategy is to look or find a pattern in the given problem. So we'll see some examples from the textbook itself. The first one, suppose there is a mathematical operation such that, see the symbol here, this is called an asterisk. Usually we use this symbol to denote multiplication. So for the time being, let's read that as the multiplication symbol itself. So suppose there is a mathematical operation into such that 2 into 4 equal to 8, 3 into 5 equal to 11, 7 into 9 is equal to 23, 9 into 7 is equal to 25. Then what is 5 into 4? So what is given in the question? We are given these inputs in the question. Let's have a look at it. 2, the symbol 4 equal to 8, 3 symbol 5 is equal to 11, 7 symbol 9 is equal to 23, 9 symbol 7 is equal to 25. Then we need to find out what is 5, that symbol 4 equal to what. So when you see the first fact here, 2 symbol 4 equal to 8, you may get the feeling that this symbol here denotes multiplication itself. We know 2 4s are or 4 2s are 8. But look at the next fact. See, 3, that symbol 5 equal to 11. Is 3 into 5 is equal to 11? Or is 5 into 3 is equal to 11? We know it's not. 3 5s or 5 3s are 15. So that means this symbol here is not denoting multiplication in this problem. It means something else. We need to identify what this symbol means here to find out the solution to this problem. So let's have a look at the other facts as well. We are given 7 symbol 9 is equal to 23 and 9 symbol 7 is equal to 25. If this meant multiplication, we know changing the order of the numbers won't change the product. If it was multiplication, it should have given you the same answer. And we know 7 nines or 9 sevens is equal to 63 and not 23 or 25. So we need to find out what this symbol actually represents or what mathematical operation it represents. So to find out what operation the symbol represents, let's have a look at the second fact. 3 symbol 5 equal to 11. We know 3 into 5 is equal to 15, but here it says 3 symbol 5 equal to 11. What should be added to 5 to get 11? We know 6 plus 5 equal to 11, and we know 6 is a multiple of 3. So if we multiply this 3 by 2 and add that to 5, we'll get the answer 11. That is 3 symbol 5. Let's check if it can be written like this. 3 symbol 5 is equal to 3 into 2 plus 5. That is 6 plus 5. 3 gets multiplied by 2 to give you 6 and add 5 to that and you get 11. So that makes sense. Here this 3 was multiplied by 2 and it was added with 5 to get 11. So let's see if this symbol here means this kind of operation. Let's have a look at the next fact and let's try to apply the same logic in the next fact. So the next fact is 7 symbol 9 equal to 23. Now, applying the previous logic, 7 into 2 plus 9. 7 gets multiplied by 2, then adding 9 to it. 7 multiplied by 2 gives you 14 plus 9 and that gives you a total of 23, which makes sense to this fact. Now let's check the remaining fact. So here also let's first multiply the first number by 2 and then add the next number to it. So that is 9 into 2 equal to 18 plus 7, that gives you 25. So yes, this logic makes sense. So this means that this symbol here does not mean multiplication, but instead it means this kind of operation. Now let's apply this logic to the problem we have. We need to find out what is 5, that symbol 4. So applying the same logic here, the first number multiplied by 2 and then adding it to the next number. That is 5 into 2 equals 10, then plus 4 and the answer is 14. So right now we have found a solution. So what did we do? So first we read the question carefully, we looked for a pattern, we identified a pattern and the pattern rule, and then we applied that rule to find the solution. So I hope this is clear to you. Now let's have a look at another example. The second one. 9 into 1 plus 2 is equal to 11. The next fact is 9 into 12 plus 3 is equal to 111. The next one is 9 into 123 plus 4 is equal to 1111. And you need to find out what is 9 into 1, 2, 3, 4, 5, 6, 7, 8 plus 9. So this is the data that we are given. So when you observe the data that you are given, when you observe that input, are you able to identify a pattern? See, the first number in this operation remains the same. It is 9. And then it is multiplied with, see, here it is 1, here it becomes 1, 2, here it becomes 1, 2, 3 and it proceeds like that. And what about the next number? Here the numbers are increasing 2, 3, 4 and so on. And when you look at the answer, you see in the answer here there are 2 ones corresponding to this number 2 and here there are 3 ones corresponding to this number 3. Here there are 4 ones corresponding to this number 4. So you see there is a pattern. So applying this same pattern rule, we can easily find out what is the final answer of this problem without actually calculating it. So are you able to do it? Let's do it. So applying the same logic here, in the final answer there would be 9 ones. So this will be the final answer. So we have read the question carefully, we looked for a pattern, we identified a pattern and the pattern rule, and then we found the solution. So we have got the problem solved. Now we'll see one more example. This is problem number 3, the third example in your textbook. Here you can see some circles and they've got numbers written inside them. and you need to identify what is the pattern used in filling up these circles. So you have a topmost circle in both the cases, you have a bottommost circle in both the cases, and you have circles in between. Observe these numbers carefully. You have the numbers 9 and 7. And in the topmost circle, in the first case, you have the number 16. Can you identify a pattern? Or can you identify how this number 16 was written? You see, this numbers 9 plus 7 is equal to 16. And let's say the next case, 15 and 12. What is the sum of 15 and 12? It is 27. So there we see a pattern that to fill in the topmost circles, we are just adding these two circles or the numbers written within these two circles. So here in the topmost circle, the number written is this 9 plus 7 equal to 16, and here it is 15 plus 12 equal to 27. Now what about the bottommost circles? Are you able to identify a pattern rule there? You may be able to identify different pattern rules for the same problem. But just like we have said before, to solve the same problem, there will be different strategies or different methods. And we know different people solve problems differently. Now look at the numbers written in the bottommost circles. Here it is 18 and here it is 30. I am able to identify two pattern rules here. One is, see, this number is the double of this one. That is 9 into 2 equal to 18. And here, this number is the double of this one. 15 into 2 is equal to 30. So that is one pattern rule I could identify. Let me share another one. So this number here, let's try to find out a connection with the other numbers in the other circles. So we know 9 plus 7 is equal to 16. And what is 9 minus 7? It is equal to 2. What if we add these two numbers? 16 plus 2. We get 18. And we have 18 here. Now let's try to apply this logic in the other case as well. So there we have 15 and 12. What is 15 plus 12? It is 27. And what is 15 minus 12? It is 3. So what if we add these two? We get 30. See, we have the number 30 here. So this rule applies here also. It works in both the cases. So you can say that is one valid pattern rule. So similarly, you may be able to identify different pattern rules for the same problem. The key is that look for a pattern and work towards the solution using that pattern. Let's see that again. About the bottommost circles, in the first case, 9 plus 7 plus 9 minus 7, that is 16 plus 2, and you get 18 here. And in the second case, you have 15 plus 12 and then 15 minus 12. 15 plus 12 plus 15 minus 12, that is 27 plus 3 is equal to 30. Now you may be able to identify different pattern rules for this problem. Anyway, the key to this strategy is to look for a pattern, identify the pattern rule, and work towards the solution using this pattern rule. So children, I hope the problem solving strategy that we learned today is clear to you. You may go through this topic, look for a pattern in page number 211 and 212 of your textbook. So once you have gone through it, just have a look at the try this exercise which is in page number 212. Try to solve it. And if you have done it, just take a picture, then send us through Teams. So that's all for today. We will see in the next class with a new problem solving strategy. Until then, bye.